The famous American writer Ursula Le Guin said in one of her works through the mouth of a character, "For a word to be spoken, there must be silence before and after the word." This phrase refers to the birth and death of all things. Every object in the universe has a beginning and an end. Some elementary particles exist for barely measurable fractions of a second. A microorganism from a couple of hours to several days. A human being lives for tens of years. Even stars that can shine for millions or billions of years eventually fade away. But what about the universe itself? Will it ever die? If so, how does it happen? And what happens after it dies? The earliest theory of the origin of our world was the theory of the stationary universe. According to this theory, our universe has no beginning and no end, has always existed and will always exist in an equilibrium and stable state. However, observations and calculations soon showed that this theory was unlikely, because in the universe there are processes in the universe that are irreversible by nature. In the 20s of the 20th century, a theory began to take shape, commonly known as the Big Bang theory. Today, it is the most developed scientific theory, explaining the origin and evolution of the universe. Dozens of scientists have contributed to the creation of the Big Bang theory. It is based on the work of Albert Einstein. As for the general theory of relativity, the main conclusion from this theory is the assumption that the fate of the universe depends on dark energy. It is a theoretical type of energy that causes the expansion of space. However, nothing definite can be said about the essence of this physical phenomenon possible. There are many theories, each with advantages and disadvantages. According to modern data, the age of the universe is counted from the moment of the Big Bang and is slightly less than 14 billion years. The universe is constantly expanding, and depending on the density of dark energy, it will either expand forever at an ever-increasing rate, or the gradual expansion will slow down and reverse. In this case, the universe will shrink back into an infinitesimal singularity, similar to the one from which it was born. The current development of science does not allow us to give an unambiguous answer to the question of which of these possibilities is more likely. On their basis, we can imagine two equivalent scenarios called the Big Bang and the Big Squeeze. The rate of expansion of the universe depends on the distance between objects and is faster the farther apart they are. Imagine a balloon with air on which two dots are marked. If you start inflating the balloon, these dots will start moving away from each other. This is how you can imagine the expansion of the universe. Space itself is expanding, and the further away the dots are initially drawn, the faster they move away from each other. At a certain distance, this speed exceeds the speed of light. This threshold is called the event horizon. All objects located beyond it disappear for the observer. It is impossible to interact with them. It is impossible to observe them. Just imagine that first the distant galaxies and their clusters will disappear from the sky, and then the stars of the Milky Way will extinguish one by one, starting with the farthest from the sun. A gloomy picture, if the Big Bang theory is correct. The rate of expansion of the universe will constantly increase, leading to the fact that gradually the forces of expansion will prevail over gravity. First, galaxy clusters will collapse, then galaxies and star clusters themselves. Then, the disintegrating star systems will no longer be able to hold the planets and satellites that are rapidly escaping into them. The next stage will be the decay of matter into atoms, and then atoms into elementary particles. Matter will cease to exist, after which the modern laws of physics will cease to work, and it is impossible to predict what will happen next. Modern observations show that space is expanding and the speed of this expansion is increasing, but we know nothing about the nature of dark energy. Therefore, it is possible that the process may reverse and the universe will begin to contract. For example, this can happen if the total gravity created by all the matter in the universe exceeds the force of its expansion. This scenario is called a big contraction, in which case the processes in the universe will continue in much the same way as they are now, until its size decreases by about 5 times its current size. Clusters of galaxies will merge into one supercluster that will occupy the entire universe. But inside the galaxies themselves will also be stars, will also be born and die, planets will form, and other events will take place. When the universe shrinks another 20 times and its volume is only 1% of the current one, all the galaxies will merge into one big one. The temperature of the relict radiation will reach 274 Kelvin and will continue to rise, which means that soon there will be no liquid water left in the entire universe, which is necessary for biological life, at least in the form we are used to. Further compression of space will lead to even greater heating of the universe. The planets will be scorched and then melted. All matter will be crushed into a huge cloud of boiling plasma. Then atoms will break apart into elementary particles, and eventually the universe will shrink into a singularity similar to the one from which it came into existence. There is a theory that is a development of the Big Bang theory called the Big Bounce theory. According to it, after the universe is compressed into a singularity as a result of the big contraction, it will be born again in another big explosion. These events will happen again and again, probably forever, as far as we can talk about eternity, beyond space and time. It is difficult to say how long any of these scenarios will take. Too little is known yet. It is possible that a Big Bang or a big contraction will occur at a time in the development of the universe when stars and planets still exist. But what if not? What will happen to the universe if the moment of the final death of the universe is in a very distant time? After all, the laws of physics are such that the universe we are used to cannot exist indefinitely. There are 4 long cosmological epochs. Each of them has its own face. We live in the so-called Age of Stars. There are still abundant reserves of interstellar gas, the raw material from which stars are formed, in the surrounding universe. New stars continue to be born, and this process will not end until all interstellar gas is exhausted. This era will end in a period of 1 to 100 trillion years. During this time, the Sun, as well as the vast majority of other stars, will exhaust their nuclear fuel reserves and turn into white dwarfs, neutron stars, or black holes. The next era is called the era of collapse, by which time there will be no more main sequence stars. Most of the matter in the universe will be concentrated in white and brown dwarfs. Leaving a little to neutron stars and black holes, all these objects will slowly cool for a very long time, approximately 10 to the 39th power of years. White dwarfs will gradually give off their accumulated heat in radiation and turn into black dwarfs. Brown dwarfs will also cool down and slow down. Thermonuclear reactions in their interior will finally stop. Gradually, most of the matter will be absorbed by black holes. At this stage of the universe's development, the main processes will be the annihilation of dark matter and the decay of protons into elementary particles that make up all the atoms we know. The proton is considered one of the longest-lived elementary particles. The estimated lifetime of a proton is about 10 to the 41st power of years. Thus, at the end of the era of decay, the matter in the universe should be a sea of scattered elementary particles, among which there are some neutron stars and black holes. The next era is called the era of black holes. According to some theories, they will gather in clusters, merging with each other until they form a single giant black hole. According to other theories, black holes will slowly evaporate, radiating energy until they finally disappear. The evaporation of black holes is a quantum effect caused by Hawking radiation. It is more intense the smaller the black hole is, and eventually deprives the whole of all its matter and energy. And this process will probably end in 10 to the 100th power of years, a number called Google. In any case, in the end, there will be only dead space in the universe, filled with the residual products of the processes that took place in previous epochs: photons, electrons, positrons, and neutrinos and quarks. Electrons and positrons gradually annihilate each other. In this form, the universe can theoretically exist indefinitely, at least until a big contraction or a big decay. In any case, humanity will not live to see this moment. Most likely, it will disappear in the age of stars. Our planet will be habitable for about 1 billion years. Then it will be scorched by the sun, which will gradually heat up. And in 5-6 billion years, our luminary, which has become a red giant by this time, will shed its outer shell and turn into a white dwarf. But what happens after the death of the universe? It is hardly possible to answer this question, because after the death of the universe, no matter what scenario it takes place, there will be neither space nor time. In the sense that we understand, even if the Big Bounce theory is correct, after the Big Bang, there will be a big new explosion and a new universe with its own galaxies and stars, and we will not know about it, just as we will not be able to learn about the previous universe that was before ours. For a word to sound, there must be silence before and after it. I hope you enjoyed this video. If you want more interesting information about space and astronomy, be sure to subscribe to our channel. Don't forget to like this video so we know you appreciate our content. Also, leave a comment with your thoughts and questions. Thank you for watching, join us, and see you soon in the depths of space.